Welcome back. This is part C of a concept video on Taylor series and Maclaurin series, which is section 10 of chapter 11. So we already saw some examples of how to write a function in terms of Maclaurin series or in terms of Taylor series. And we every time we gave a radius of convergence as well. Now let's try Maclaurin series for cosine x. Just the way we did Maclaurin series for sin x, we can also do cosine x. That is one way of doing it right from scratch. Or we can actually take the derivative of sin x that we expanded it and we have an expanded version of sin x. And then we can also take the derivative of the sin x and give the Maclaurin series representation of cosine x. But instead of doing it that way, we can do this problem right from the formula. So we will just do the problem exactly similar to the way we did sin x. So let's write down the first step and we'll write down what Maclaurin series is. Maclaurin series, it is a series centered at the origin, centered at 0. So f of x equal to cosine x equal to expanded version is f at 0, f prime 0 over factorial 1x, f double prime 0 over factorial 2x square, nth derivative at 0 over factorial n x to the power n, etc. If you write the same thing in sigma notation, it would be nth derivative at 0, sigma nth derivative at 0 over factorial n x to the power n varying from 0 to infinity. When we say fx, in this particular problem, it is cosine x. So what we are going to do is to find out these coefficients, the derivatives. So let's start with the given function, which is equal to cosine x, and its value at 0 is cosine 0, which is equal to 1. Then f prime 0 is negative of sine x. Then if you take f prime x would be negative sine x. And if you evaluate that at 0, it is negative sine of 0, which is 0. Then f double prime x is negative cosine of x. F double prime 0 is negative cosine of 0, which is equal to negative 1. And if you take the third derivative, it's negative of negative sine x, so it will be sine x. If you take the third derivative at 0, is sine 0, which is equal to 0. If you continue this process, you notice that the second term, second coefficient, fourth coefficient are all 0. The first coefficient, and the third coefficient are going to alternate in sign. So if you put this information just like the previous problem into, if you substitute all of these values into this step 1, you get cosine x, f of x, which is f at 0, which is 1, f prime 0, which is 0, then f double prime 0 over factorial 1 times x, Then f double prime 0, that will be f double prime 0 equal to negative 1. So negative 1 over uh, factorial 2 x square. Then the next term would be 0. The next term would be 1 over factorial 4 x to the power 4, etc. That is 1 minus x over factorial minus x square over factorial 2 plus x to the 4 over factorial 4 minus x to the 6 over factorial 6, etc. In sigma notation, if you write this in sigma notation, you have to write only in terms of even exponents. So it will become sigma n varying from 0 through infinity, negative 1 to the power n, x to the power even exponent, that is 2n, over 2n factorial. That is the sigma representation or Maclaurin series representation of cosine x. As usual, we have to do the radius of convergence part. Finding radius of convergence. So for this, you apply the ratio test. So a sub n plus 1 over an is negative 1 to the power n plus 1 x to the power 2 times n plus 1 divided by 2 times n plus 1 factorial. Every n must be changed to n plus 1. Don't forget the parentheses. They are dividing this by an, so you will have to take the reciprocal and multiply. This will be 2n factorial over negative 1 to the power n x to the power 2n. So we'll simplify this. Negative 1 to the power n, negative 1 to the power n plus 1. This will throw a negative 1. So this will be equal to negative 1 x to the power 2n plus 2 divided by 2n plus 2 factorial. You distribute the 2. Then 2n factorial divided by x to the power 2n. So if we do further simplification, this will become x square. Then the usual trick we are going to do here, it is 2n factorial times 2n plus 1 times 2n plus 2. So 2n factorial get cancelled out. So when you take limit n approaching infinity of absolute a sub n plus 1 over an, which is limit as n approaching infinity of absolute negative 1, which will be 1, absolute x square, which is just x square, divided by 2n plus 1 times 2n plus 2. All this will become 0 because the denominator is involving n. So by ratio test, this is the limit which is smaller than 1. Therefore, the Maclaurin series for f of x converges, and it converges for all values of x. So by ratio test, you can conclude cosine x, which is written as negative 1 to the power n x to the power 2n over 2n factorial, converges for all x, and then the radius of convergence is infinity.